Good morning, class. We are looking at pre-calculus practice test number 4, module 4, covering chapter 8, application of trigonometry, polar coordinates, and vectors. Here's the second part, part 2, polar coordinates and vectors. All right. Plot the points in polar coordinates. First and foremost, let's understand what polar coordinates are. Basically, we have a pole, which is the same as the origin, if you think of a rectangular coordinate system, and the x-axis. That's a polar axis. But in order to make it easy to understand the concept, then we have this vertical axis, just like the y-axis, so on and so forth. But it is basically the pole and a polar axis. That's all there is to it. And it starts with r and then theta, as far as the writing goes. So the first number is r, which represents the distance, and theta, which represents the angle. Now, in order to plot this properly, you start with the second part, which is theta. So you need to know the angle. In this case, if you look at this one, the angle will be 0, and we go -2 to the right. That means 2 to the left. And that would be the plot of that. For the next part, again, r comma theta, look at the second part, pi over 2, in essence, give us the vertical axis. You can call it the y-axis if you will. And we go how many units? 1 unit up. So it looks like that. Given this part B, 1 comma pi over 2, we want to find other polar coordinates, because polar coordinates are not unique. There are infinitely many different ways we can represent them as follows. If we have r and theta, we can add 2k pi, k is an integer, meaning even multiples of pi, like 2 pi, 4 pi, 18 pi, you name it. If you change the r to negative, then this one you have to add a pi to it. What this means, if you look at these two combined, refer to the fact that you are negating r and you're adding an odd multiple of pi, such as 3 pi or 5 pi or 7 pi. That's the meaning of it. In this case, it says we want r to be positive, okay? So we're going to keep it as positive, which means we're going to keep it as the same answer, 1. What we want theta to be between 0 and -2 pi. Therefore, this one just subtract multiples of 2 pi. In this case, subtract 2 pi. So if I subtract 2 pi, here's the pair, 1 comma -3 pi over 2. In this case, we said we need r to be negative. So you're going to change this to negative. But going back here, how do you make it negative? Then you need to add odd multiples of pi. For example, you can just add 1 pi. So if you add pi, you get -1 comma 3 pi over 2. We want it to be between 2 pi and 4 pi. Let's add 2 pi to pi over 2. And I hope you realize this pair, 1 comma pi over 2, can be represented by those 3 different ones. The last one is 1, 5 pi over 2, meaning this is not unique. And that's important to understand. Plot the point first, then find their coordinates. So this, we want to find the rectangular coordinate for this. This is a polar format. And in order to graph this, basically, the grid that I have here, I show you the rectangular grid as well as the polar grid, which is a bunch of circles, if you will. So the very first thing you do, you find 150 degrees. So this is the positive side of the x-axis. You go with 150 degrees, and then you draw a line. And along that line, we go how many? 6 units. So you start counting 1, 2, 3, 4, 5, 6, and that's the point. This is how you plot the point. And if you want to go to rectangular coordinate system, polar has coordinates r theta, rectangular has coordinates x comma y, such that x is r cosine theta, y is r sine theta. Therefore, we are going to plug in r is 6 and theta is 150 degrees or 5 pi over 6. It doesn't matter. You can write 150 degrees or 5 pi over 6. You do the math, and you end up with negative 3 square root of 3 for x. By the way, 5 pi over 6, it puts us in the second quadrant. So it has the same value as pi over 6. Cosine happened to be negative, and sine happened to be positive in the second quadrant, which is 1/2. And we end up with the following. 6 comma 150 is the same as negative 3 square root of 3 comma 3. So again, let me just make a point here, or 150 degrees, because you keep it as degrees, either way is fine. Now we have the rectangular coordinate system point 2 comma negative 2, and we want to go with the polar coordinate. So you go 2 units to the right, 2 units down. Okay, so 2 units to the right, 2 units down, and you end up here. And now the relationship is x squared plus y squared equals r squared. Tan theta is y over x, and you should always pay attention to the location, so you adjust for the quadrant. So having said that, let's calculate x squared plus y squared, which becomes 8. So r squared is 2 squared plus negative 2 quantity squared, which is 8, and r becomes 2 squared of 2. As far as tangent theta is concerned, is y over x, so negative 1. And theta is negative pi over 4. And you can write it in this fashion, that this pair, 2 comma negative 2, in a rectangular coordinate system is this pair in polar coordinates. Bear in mind that if you want to stick with a positive value, this negative pi over 4 is the same as 7 pi over 4. And either way is fine. Transform the polar equation r cosine theta equals negative 2 to an equation in rectangular coordinates and graph. So again, we have all the information we need from polar to rectangular and vice versa. And we are going to write that r cosine theta is given as negative 2. Also, we know x is r cosine theta. So what does it mean? X must be negative 2, which results in a vertical line. It is a vertical line. And that's the final answer. X equals negative 2. Again, as you can see, this is negative 1, negative 2 along the x-axis. So you go 2 units to the left and draw a vertical line. Again, this point, the x-intercept is located at negative 2, 0. Let's make a note of it. We're going to do the same thing. We're going to transform the polar equation, but this time the equation is r equals 2 cosine theta, an equation in a rectangular coordinates. And we're going to graph. Again, the information needed is here. And so all we have to do the math. So r is 2 cosine theta. X is r cosine theta, and r squared equals x squared plus y squared. So it so happened that for a case like this, as we look at those, it gives us a specific methodology or a trick, if you will. So if you look at this one, on the right side, if it happened to have r, somehow becomes x. And on the left side, if it was r squared, we would have x squared plus y squared. So the trick is to multiply this by r. So the whole equation, when we multiply by r, we get r squared equals 2r cosine theta. And we replace it. We replace the r squared with x squared plus y squared, and 2r cosine theta with 2x. So x squared plus y squared equals 2x. You may recognize this is the equation of a circle, but let's work it out to see how it works. We bring 2x to the left. And when we put these two together, I hope you realize this is requiring completing the square. So in this case, b equals -2 divided by 2 is -1, and square it, you get +1. We're going to add to both sides. Left side becomes x minus 1 quantity squared plus y squared equals 1. And x minus h squared plus y minus k squared equals r squared, the equation of a circle centered at h and k. So it is centered at 1, 0. Radius is square root of 1, which makes it 1. So we proved it's a circle. The center is at 1, 0. That's the center. And the radius is 1. So you draw it, and it looks like that. All right. We want to do the same thing, transform the polar equation, but this time is r cosecant theta equals 8 to an equation in rectangular coordinates and graph it. So let's rewrite cosecant as 1 over sine. Cross product gives us r equals 8 sine theta. And I hope you see that it's similar to the previous one. If we had an r on both sides, this would become r squared, and this is 8r sine theta. And that gives us a situation we can easily handle. So let's multiply both sides by r. So it gives us r squared equals 8r sine theta. Again, this is x squared plus y squared. Let's write it down. X squared plus y squared equals r squared. Y is r sine theta. So replace it, and you get the following. X squared plus y squared equals 8y. So pretty similar to what we had in the previous page. We move the 8y to the left. And now we're going to combine these two. And complete the square. In this case, b is -8 divided by 2 becomes -4. Square it becomes a +16. We add it to both sides. So this remains, this becomes y minus 4 quantity squared equals 16. Again, comparing it to the circle in standard form. This is a circle centered at 0, 4. The radius is square root of 16, which is also 4. So 0, 4, you start counting and going up 4 units, 0, 4. Look at the circles. This is 1, 2, 3, 4. And then, okay, you draw a circle with the radius 4. Identify, graph the equation and convert to a rectangular equation. Again, a bunch of information at the bottom. X equals r cosine theta. Y equals r sine theta. X squared plus y squared equals r squared. Tan theta is y over x, and account for the quadrant. All of the above. So let's see if we can do that. If we square both sides, again, there are some tricks involved. R squared becomes 16. And as you know, R squared is x squared plus y squared. And the equation of a circle centered at 0, 0 has the equation x squared plus y squared equals r squared. I'm reminding you of the formulas we've seen. And so this is a circle centered at 0, 0, or the pole or the origin, with the radius square root of 16 equals 4. So that would be the graph. The next one, theta is equal to 3 pi over 4. We can take the tangent of both sides. Because we know tangent is y over x, something interesting will happen. So tan of theta is tan of 3 pi over 4. And we know it's equal to y over x. And tan of 3 pi over 4, remember, second quadrant tangent is negative, the same as pi over 4, 1, but the negative sign. So tan theta, which is y over x, equals -1. The cross product results in y equals -x, which is a line through the origin going this way. So line y equals -x. So these are some interesting questions that we have seen, and we are going to look at more concepts. By the way, pay attention to the way I have this set up. Theta is 0 here, pi over 4 here, pi over 2 here, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4. And obviously, I'm looking at easy arcs or angles, okay? Let's look at this one. Identify, graph the equation, and convert to a rectangular equation. R sine theta is given as -3. And again, you look at all of this. This is because we want to make sure we have all the information. Remember, y is represented by r sine theta, right? Therefore, if that is the case, y must be -3, which gives us a horizontal line Okay, so you just go along the y-axis 3 units down. Do that. If you were to pinpoint the y-intercept would be located at 0, -3. Our cosine theta, we go back to this one, our cosine theta is x. Therefore, x must be 4, which gives rise to a vertical line, x equals 4. And let's do the same thing here. Let's pinpoint the x-intercept at 4, 0. So we are just making it general. And it's important when you draw vertical lines, horizontal lines, come up with the intercepts, and they have only one intercept. All right, so the synopsis of what we have done is as follows. If R is a constant, is a number, we end up with a circle, which has the center at the pole with the radius A. If we have R sine theta equals a constant, that's a horizontal line. That means y equals A. If R cosine theta is A, that's a vertical line, x equals A. Theta equals a number, a constant. This is the line y equals tan theta times x. We did a simple example like that. So this is a horizontal line, this is a vertical line, and the following. If we have r equals 2a cosine theta, or -2a cosine theta, or 2a sine theta, or -2a sine theta, all of them are circles. And by the way, we are assuming a is positive. In this case, when we are dealing with cosine, okay, either a comma 0 or -a comma 0, it goes along the x-axis. If we have sine, we have either 0a or 0 minus a, it goes along the y-axis, the center. And all of them have the same radius a, which is half of this number, the absolute value. Because we wanted to make sure we have a, we went with 2a here, just to make sure it makes perfect sense to everybody. Now, what happens as far as the symmetry in polar coordinates is concerned, let's quickly discuss that. Could you please read this for us? Do you mind?
Just the whole thing.
Please.
Okay. Symmetry in polar coordinates. Symmetry with respect to WRT, the polar axis, x-axis. If in the polar equation r comma theta can be replaced with r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. Symmetry WRT, the line theta equals pi over 2, y-axis. If the polar equation r comma theta can be replaced with r comma pi minus theta, the graph is symmetric with respect to the line theta equals pi over 2, y-axis. Symmetry WRT, the pole origin. If in the polar equation r comma theta can be replaced with negative r comma theta or r comma theta plus pi, the graph is symmetric with respect to the pole.
Perfect. I put WRT because I use that from time to time, which is the synopsis of symmetry with, or sometimes symmetric, with respect to. The WRT, with respect to. So what do we mean by this? I want to make sure we understand the concept that is explained here. If you take a look at this one, okay, this is your polar axis. You can think of the x-axis, okay, or the positive side of the x-axis. So if we could change theta, take a look at this line, for example. If we could change theta to negative theta, that creates symmetry with respect to this line or the polar axis. So as long as we get an equivalent equation. Here's a second case. Remember, theta equals pi over 2 in essence is your y-axis. We don't really have a y-axis when it comes to polar coordinates. We have a vertical axis and vertical line. Theta equals pi over 2. I hope you realize that a line is represented with an simply angle. Theta equals pi over 4, theta equals pi over 2, so on and so forth. Now, theta equals pi over 2 in essence is your y-axis. So if we have r theta and we can replace it with r comma pi minus theta, I hope you realize this angle is theta. So is this angle in essence. So this makes it pi minus theta. Okay, this is how they arrive at this is theta. So this whole thing is pi. This whole thing is pi. So pi minus theta. So if you can replace it with pi minus theta, then we also have a symmetry, but this time with respect to theta equals pi over 2. Finally, if you look at the origin or the pole, r comma theta, okay, it changes to negative r comma theta. If we want to keep the r positive, remember how we can do that? We can add odd multiples of pi. So simply add pi. So this is the same as negative r comma theta or r comma theta plus pi. Those are different symmetry that are available in the case of a polar. And sometimes if you use them, they will really help you with the graph. I will explain it with a simple example. And we take it from there. We want to graph r equals 1 minus cosine theta. The first thing I want to tell you, if you want to graph in polar coordinates, just plot points. That's all. And you start and you'll see the trace, you come up with the answer. So how do you do that? You start with theta. Then you calculate the r, and then you write the pair r comma theta. Now, always use easy ones so you don't need the calculator, which means you're going to use common arcs. For example, in the first quadrant, like 0, pi over 6, pi over 4, pi over 3, and pi over 2. So, by the way, this is just to remind you, if we happen to have a graph a times 1 plus minus cosine theta, or r equals a times 1 plus minus sine theta, they are called cardioids because it looks like a heart shape. And it passes through the pole when a is larger than 0. So look at the angles that I picked. First, think about 0 to pi over 2. You can ignore the rest and then do the same thing. Pi over 6, pi over 4, pi over 3, pi over 2. I picked up only common arcs. Now, between pi over 2 and pi, I can do the same thing. I just picked 2 pi over 3, but I can pick, for example, 5 pi over 6, 3 pi over 4. They are all common arcs, and sometimes you must. Sometimes you must. So that's theta. But what is r? So as an example, if I plug in 0 here, what happens? Cosine of 0 is 1. 1 minus 1 gives me 0. So this is what I'm going to do with the second column. If I plug in pi over 6, I hope you realize cosine of pi over 6 is square root of 3 over 2. And if I plug in 1 minus square root of 3, 2, it's you need a calculator to sort of figure it out. And you continue with pi over 4, cosine square root of 2 over 2. Pi over 3 is a good number because it's just 1/2. You follow what I'm saying? Pi over 2, cosine becomes 1. 2 pi over 3 is the same as a pi over 3, but this time negative. Okay. And so it's minus negative 1/2, and pi gives you negative 1. 1 minus negative 1 gives you 2. So take a look at what happens. Again, all you have to do, replace the theta with those values, easy ones, all of them, and write now the pairs. So in order for you to plot those pairs, you have to start with theta. You have to start with theta. So again, a quick recap. Theta, this is in the first quadrant up to here. From pi over 2 to pi, you can pick more points. But the reason 2 pi 3 is really a good one because cosine of 2 pi over 3 is the same as cosine of pi over 3. It's 1/2, but in the second quadrant makes it -1 minus -1/2 makes it 3/2. However, if you look at this one, square root of 3 is about 1.7. You have to divide it by 2 becomes about 0.85. Subtract it from 1 becomes about 0.15. It's not a nice and easy number. That's why in the second quadrant, I just picked 2 pi over 3. And of course, pi over 2 and pi are easy numbers. Now take a look at the graph, and I want to show you just the ones that we did. The first one we did 0, 0. Okay. Now this is easy. Pi over 3 is 1/2. Okay, so you draw a pi over 3 angle with respect to the x-axis, and then you go only half a unit. Okay, now pi over 2 is easy. Is just think of the y-axis, and for pi over 2 you go 1 unit. So look at those 3 pairs only for now. Another one now, so right here, this right side is really the 0 to pi over 2. And those are easy numbers. Can we have more points, such as pi over 6 and pi over 4? By all means. But those are good enough. When we go to the second quadrant, we just pick 2 pi over 3, which is 3/2. So you draw 2 pi over 3. This angle is 2 pi over 3. And you go 3/2, 1.5. And of course, along the x-axis on the left side, you go 2 units. This is 2 comma pi. Now, we can continue with these thoughts by going to the third quadrant and the fourth quadrant. We have the graph. It's a good practice to take a look at what happens when it comes to the concept of a symmetry that was discussed. Notice if we change the theta to negative theta, it makes no difference. Cosine of negative theta is identical to cosine of theta. Therefore, it's symmetric WRT with respect to the polar axis. R theta can be replaced by R comma negative theta, resulting in an equivalent equation. The graph is symmetric with respect to polar axis, which simply put means repeat. So just it looks like that. So if I want to follow that, I'm going to graph class. I'm going to graph. Okay, I'm going to bring this down. I'm going to bring this down, and I'm going to, this point crosses here. Okay. So I go here, and then I continue and bring it down here. If I want to follow that, I do not have to have more points. That's good enough. However, for 4 pi over 3, 3 pi over 2, 5 pi over 3, and 2 pi, those are easy numbers. We plug in, we get 3/2, 1, 1/2, 0. And we plot those pairs. Again, as an example, 4 pi over 3. It is the same as pi over 3, which is 1/2. In the third quadrant is negative, so it's -1/2. 1 minus -1/2 makes it +3/2. Just as an example, 3 pi over 2, obviously, remember pi over 2 multiples of pi over 2, and they are odd. They put us along the y-axis, if you will, a vertical axis, resulting in 0 for cosine. And it continues with 5 pi over 3 is the same as pi over 3. And in the fourth quadrant is positive. So 1 minus 1/2, which gives us 1/2. 2 pi gives us +1. 1 minus +1 is 0. So back at 0, you don't have to even write 2 pi. 2 pi repeats when 0 and 2 pi are identical. So it looks like this. If you look at this one, if we followed just the symmetry, it would have done the job. And now following more points will repeat the same thing for us. Plot the complex number 1 plus I in the complex plane and write it in polar form. write theta in degrees. If it doesn't say so, you have a choice. You can do it in degrees or in radians. So let's look at a couple of things. Z, normally we use Z to represent a complex number. If you see it in any other format, that's fine. X plus yi, and it's r times cosine theta plus I sine theta. This we simplify to r cis theta. C stands for cosine, I in front of a sine, and S stands for sine. R cis theta. So this notation can be simplified into this. Okay, complex format, polar format, where r squared is again x squared plus y squared. The absolute value of z refer to its size, which is equal to r squared of x squared plus y squared, and tan is y over x. A lot of things are being repeated here. Here's the complex plane. Here's the real line. Here's the imaginary line. Real line along the x-axis, imaginary line along the y-axis. Okay. And here's the r, here's the theta. I hope you remember for polar, we need theta and r. Okay. And this is z, and this is its complex conjugate, where positive iy changes to negative iy. Sometimes they use it as z bar, sometimes z star. It depends on the text. So you may see, instead of this one, you may see this one. Sometimes they even use z prime. Okay, but z bar is more often used. All right, so we are going to plot the complex number 1 plus I in the complex plane and write it in polar form. This is 1. So in other words, this is x plus yi. X is 1, y is 1. That means go 1 along the x-axis, meaning the real line, and 1 along the y-axis, meaning the imaginary line. Okay, 1 and 1, and that's the point. So it's, you can think of it as x and y, but again, this is the real axis, this is the imaginary axis. So sometimes they just call it RE, and this one IM. So also let me write that. So many times you see this one RE, and this one as IM, short for imaginary, short for real. Okay, so let's calculate the R using the formula squared of x squared plus y squared, knowing that x is 1, and this is when we don't have anything, that means 1 times I. So the value of y is also 1, giving us square root of 2. To find the angle, y over x is 1, giving us 45 degrees. And therefore, this can be written as R cis theta, where theta is 45 degrees. So R cosine theta plus I sine theta, cosine theta, theta changes to 45 degrees. Or you may write it as square root of 2 cis 45 degrees. This is a shorthand notation. You may find it handy, and they use that from time to time. All right. Again, we have that. This, by the way, what we were looking at, R cis theta, is also known as Euler's formula. We are rewriting the whole thing. We want to write this, the complex number in rectangular form, and plot the complex number. We simply put, you want to multiply it, you want to evaluate this. And to do that, 7 pi over 4 is the same as pi over 4 cosine of pi over 4 square root of 2 over 2. In the fourth quadrant, cosine is negative. This is also the same as pi over 4, but sine is negative in the fourth quadrant. So pay attention why we have a negative sign here. Because in the fourth quadrant, sine is negative. We are going to multiply by 4, and there you have it. So you want to graph this. The very first thing you do, notice this angle of 7 pi over 4. If you want to go with that, remember square root of 2 is about 1.41. So 2 times that is about 2.82. The same thing here, 2.82. But this goes along the x-axis, 2.82. This goes down because it's negative by 2.82, and it gives you this point. If we were to follow that, okay? So again, you really have to change the square root of 2. And with that, again, let me write that. So square root of 2, as I mentioned, is about 1.41. Okay, so this is about 2.82. So 2.82 this way, 2.82 down, and it results in this point. Or here's 7 pi 4. I hope you remember that. Okay, and so that's the point. Either way, you come up with the proper answer. Find z times w and z divided by w, and leave the answer in polar form. Z and w are given. Well, let's remind everybody how we do the math. First of all, z is r cis theta and all of this information. If you're multiplying two complex numbers, multiply their size, r sub 1 and r sub 2, and then cis theta 1 plus theta 2. So you're multiplying their modules, they call them sometimes. This is called the module. If you're dividing by one by the other, you divide their modules and then you subtract the second angle from the first angle. So let's follow that. I'm going to multiply these two. So we're going to multiply these two numbers. Both of them happen to be 2. They don't have to be. 2 times whatever this number is. So 2 times 2 is 4. And then according to this formula, cosine of pi over 8 plus pi over 10 plus I sine of pi over 8 plus pi over 10. According to this formula, everybody. According to this formula. So all you have to do, add them up. I'm assuming everybody can see between 8 and 10. The LCD is 40. And then so you have 5 pi and 4 pi, okay? In this case, 40 divided by 8 is 5 pi, 4 divided by 10, 4 pi and 5 pi, they add up to 9 pi, okay? So 9 pi over 40, and this 4 is the product of these two numbers. And you're done with their product. Now we are interested in their division. So we're going to write z over w, and we write the z in the numerator, w in the denominator. Needless to say, these two numbers are identical. They cancel each other. And according to this formula, okay, they are gone. Now cis theta minus 1, theta minus theta 2. So pi over 8 minus pi over 10. Pi over 8 minus pi over 10. Again, the common denominator is 40. So this is 5 pi minus 4 pi over 40, which gives you pi over 40. I'm assuming nobody has any problem adding and subtracting fractions. So that shouldn't be a big deal. So product rule for complex numbers, multiply their modules, add up their angles, if you will. Division, divide their modules, subtract their angles. We want to write this in standard form, a plus bi, where this expression is in polar and it's being raised to the power of 6. So how do we tackle that? That's what we are going to discuss. Again, we know all of those. We are adding this last piece called Demoir's theorem, which indicates if you have a complex number and you want to raise it to the power, any power such as n, then you raise the module r to the power of n, and then you multiply the theta by n. In essence, following the concept of a multiplication that we add up their angles. So there are n of them. That is very simple to see. And so with that being the case, let's see how we do that. So we want to raise this, and let's call it z to the power of 6. So we're going to follow this. We're going to raise the number square root of 3 to the power of 6, and we are going to multiply the angle by 6. Clearly, this one goes away. This one goes away, this one becomes 3, right? The same thing happens here. Now, square root of 3 to the power of 6 is the same as 3 cubed. I hope you realize that. Because this is 3 to the power of 1/2. 1/2 times 6 is 3. Now, everybody knows 3 cubed is 27. Now, 5 pi over 3, the arc that you can use instead of that is pi over 3. Reference arc. They call it reference arc, and they use, for this one, they use theta prime. I've mentioned it last time. Theta hat, you name it. So it's the same as pi over 3. You have to figure out if it's positive or negative. Now, cosine of 5 pi over 3. 5 pi over 3 puts us in the 4th quadrant, which means cosine is positive, sine is negative. That's why this doesn't change, but this one positive changes to negative. Pay attention to the sign. Needless to say, 3 cubed is 27. Now, what is cosine of pi over 3 is 1/2. Sine of pi over 3 is square root of 3 over 2. You apply the 27 to each and every one of them, and that's the final answer in standard form. Given z equals 1 plus I, find z to the power of 10. We had done this before. I hope you remember. You can go back to question number 9. We did this and we came up with square root of 2 cosine 45 plus I sine 45. We already have done this, so I'm not going to repeat that. And we're going to follow this. Z to the power of n is 10. So z to the power of 10, that means raise this to the power of 10 according to this, and multiply the angle by n, which is again 10. Square root of 2 to the power of 10 means 2 to the power of 5. 10 times 45 means 450. Now, 2 to the power of 5, everybody knows is 32. 450 is larger than 360. Subtract 360 and it doesn't change anything. So subtract 2 pi or 360 degrees and they both become 90. Cosine of 90, we know it to be 0. Sine of 90, we know it to be 1. And the final answer is 32i. 32i. So that's dealing with powers for complex numbers known as Demoir's theorem. What if we want to find complex roots? According to the theorem, if you want cube roots, there are 3 of those. If you want the fourth roots, there are 4 of them. So this is the repeat of what we have seen. We are going to add this. If a number is in this form, r cosine theta 0 plus I sine theta 0. For n larger than or equal to 2, There are n distinct complex nth roots of this number, W. How do you find that? You want the nth root, so you take the nth root of R. And how do you find the nth root of this? You have to divide this by n. And in order to find each and every one of them, we're going to add 2k pi. So if I change theta 0 to theta 0 plus 2k pi, it's absolutely fine. And now I'm going to divide it by n. In essence, theta 0 plus 2k pi over n. Or just separate them. It doesn't make any difference. Remember, by 2k pi, we means 360 degrees. So you can say 360 degrees times k divided by n. It's the same thing if you want to go with degrees divided by n. And what do? You replace the k starting with 0, 1, 2, all the way to n minus 1. If you add n, it brings you back to the first one. I want you to know that that's why. And you can see it when you go through that. So in this case, we want the cube roots. Let's find it. W or 8 is 8 cosine 0 plus I sine 0. I hope you know that any number that has only the real part, it's along the x-axis. So the angle is 0. So because cosine of 0 is 1 and sine of 0 is 0. So there is no I involved. That's why. So it's 8 cis 0 or 8 cis 0, however you want to write that. The 0 degrees or 0 radians are the same. I want you to know that. And so either way is fine. So having said that, we are going to go with this formula. We are looking at this formula where the original angle is given as 0. And we're going to add 2k pi over n. And remember what's n? Cube roots means n equals 3. All right, so you take an nth root in this format. So what is the cube root of 8? We know it's 2. So 2 cis, and this is 0, so it goes away. Only this part where k is 0, 1, 2, all the way to n minus 1, all the way to 3 minus 1. So simply 0, 1, 2. All right, so we are going to put 0, 1, and 2 instead of k. So let's see what happens when we put 0. 0 gives us 2, clearly, and obviously cube root of 8 is 2, that's 1. Remember, there are really 3 roots, because when we say cube root of 8, you said equal to x, that means x cubed equals 8. That's the meaning of it. And so becomes 2. Now 2 pi over 3, that means cosine of 2 pi over 3, I sine of 2 pi over 3. So let me write one of them so you see how that works. This means 2 times cosine 2 pi over 3 plus I sine 2 pi over 3. And 2 pi over 3, the cosine is, both of them are the same as pi over 3. But in the second quadrant, cosine is negative, sine is positive. So the same as pi over 3, cosine is 1/2. So this becomes 1/2. Let's just write that. So cosine of pi over 3 is 1/2. In the second quadrant, cosine is negative. Plus I times, now 2 pi over 3 is the same as pi over 3, sine is positive, square root of 3 over 2. Now apply the 2, and the denominator goes away. So I want you to see this one here. And I'm going to leave you the last one to do it on your own, convince yourself it's this one. Now, it is important to see what happens if you choose by mistake one more number. Let's say is 3. I hope you see that if you put number 3 instead of k, this 3 cancels out the 3, and you're adding 2 pi, which is the same as 0. So again, it doesn't matter if you make a mistake, you should be able to catch your mistake. Repeat, if I go with number 3, k is 3, and 3 cancel each other, you get 2 pi. 2 cis 2 pi, which is the same as 2 cis 0. So if you choose the next number, you get back to the first one. That's why it stops as it was mentioned here. Vector V has initial point P and terminal point Q. Write V in the form of AI plus BJ, find its position vector, also find its magnitude. This is called the magnitude. P has coordinates 3, 2, Q has coordinates 5, 6. So let's quickly recap the information about vectors. When you look at along the x-axis, the distance of x sub 2 minus x sub 1, and along the y-axis, y sub 2 minus y sub 1, then that's how you write P1, P2. And if you move this initial point to the origin, then what you are, in other words, in this case, x sub 2 minus x sub 1 is A, y sub 2 minus y sub 1 is B, then this is called the position vector. All right, position vector V. If V has coordinates AB, is an algebraic vector whose initial point is at the origin, then V is called a position vector, as I mentioned here. So take a look at the graph. Algebraic vectors are written either in this form with I and B, or in this form with AB. And A and B are called components of the vector. In other words, component along the x-axis, and this is B along the y-axis, or along the horizontal axis, along the vertical axis. A vector with initial and terminal points given as such, x sub 1, y sub 1, and x sub 2, y sub 2, is equal to position vector V, or vector PQ. This is the notation for vector when you put it at top. X sub 2 minus x sub 1, these are the components, and y sub 2 minus y sub 1, these are the components. So if I want to come up with that, x sub 2 minus x sub 1, therefore we are going to write the second one, which is 5, 6. Okay, so we're going to put 5 minus 3, and then 6 minus 2, and that results in 2, 4. This is absolutely fine if you want to write it in this format. If you want to write it in the form of AI plus BJ, then we just tag along I and J, that's all. So 5 minus 3I plus 6 minus 3J, which is simply 2I plus 4J. Both are absolutely fine. You represent them just the way they ask you for 4 credit. Now, the magnitude of a vector is defined. The magnitude of the vector is the square root of, you square its components, a squared plus b squared, and you add them up. It is always positive. In the worst case scenario is 0. If it is 0, then the v must be 0. And the magnitude of a negative vector with the positive vector are the same, negative v and v. If you multiply it by a, you can take the a out in an absolute value form. So those are some properties of vectors. And let's find the magnitude for this question. Magnitude using this formula is 2 squared plus 4 squared. That gives us 4 and 16 is 20, square root of 20. And I hope you realize this is 4 times 5. 4 comes out as 2. 5 remains. So we have 2 square root of 5. That's one way to represent it. Given v equals negative 2i plus 3j, w is 5i minus 4j, we want to find the magnitude v We want to find v plus w and 2v minus 3v. And again, this is the synopsis of what we had before. Let's start with the magnitude. Okay, so that means the magnitude of v, we are going to square -2, and we're going to square +3. This gives us 4. This gives us 9. They add up, and we get square root of 13. We can leave it as a precise number. What about v plus w? You just add them up. How do you add them up? Just add up like terms. If you're subtracting the same way. So -2i and 5i, those are like terms. 3i, +3j minus 4j is minus j. Just add up like terms. It's really that simple. Same thing happens here. 2 times v minus 3 times w. So 2 times v minus 3 times w. That's all there is to it, just as you do basic operations in algebra. So we're going to distribute the 2, we get -4i plus 6j. We're going to distribute the -3, we get -15i plus 12j, and we add up like terms. -4i and -15i gives us -19i, 6 and 12, 18j. And that's it. Also, I wanted to show you the graph just to remind you, if you're adding u and v, the methodology is that the terminal point of u and the initial point of v, they get together, and the resultant u plus v would go from the initial point of u or the initial point of the first all the way to the terminal point of the last one, which is v, u plus v. Now, if we want to add this to w, then this is what we get. Okay, this is just to remind you as far as the methodology. You can do it with a triangle and do the math, or parallelogram. Either way is fine. There are different methodologies that you can use. We want to find the magnitude, direction angle, and a unit vector in the same direction for this vector. So let's start with what we know, magnitude. V is 3i plus 3j, so a is 3, b is 3, put it into the math. So we're going to square each one, we get 9, 9 is 18. And I hope you know this is 9 times 2, 9 comes out as 3, becomes 3 squared root of 2. So that's the answer for the magnitude. But what is a direction angle? Let's remind everybody. A vector can be shown as the product of its magnitude and cosine alpha I plus sine alpha j, the I direction along the x and the j direction. Those are called unit vectors. Unit vector along the x-axis is I, along the y-axis is j, and alpha is the angle that it makes. With the positive side of the x-axis, it's between 0 and 360. So in short, we want this angle. That's all there is to it. And so again, we use tangent. We know v is 3i plus 3j, and tan is y over x is 1. And we know it's in the first quadrant, right? 3 units along the x-axis, 3 units along the y-axis puts us in the first quadrant. Since we know that, then it gives us 45 degrees or pi over 4. So that's the direction angle. The next one is to find the unit vector in the same direction. In other words, this vector has this magnitude. We want to shrink it in such a way that its magnitude, so if it goes up there, let's say, you want to shrink it such that it becomes a vector with a magnitude equal to 1. So all you have to do, divide the vector, so let's write it down, by the magnitude. So by the way, this one, this direction angles, I have to write the magnitude times cosine alpha I plus sine alpha j. That is 3 square root of 2 cosine 45i plus sine 45j. I didn't finish that, so I want to go over that. So you plug in this one, and if you find cosine 45, sine 45, and apply, you get to the same answer, by the way. You do get to the same answer. But that 45 degrees gives us the angle. So sorry. Now, the last part is the unit vector. How do we get to the unit vector? We simply divide by the magnitude. So divide by magnitude. As far as the unit vector, A is A times 1, 0 plus B times 0, 1 is AI plus BJ. So you divide by 3 squared up 2. They cancel each other. We get 1 over square root of 2. And 1 over square root of 2 is the same as square root of 2 over 2. And we are done. So a quick recap before we move on. What is the magnitude? Square root of a squared plus b squared. Direction angle, the angle that the vector makes with the x-axis. How do you find it? Tan of alpha is y over x. Now you pay attention to the quadrant, and then you can write it as the product of the magnitude that you found, cosine 45 degrees cosine alpha I plus sine alpha j. That's the direction. And in order to find the unit vector, all you have to do, divide the original vector by its size, its magnitude. Could you please read this?
Write the vector v in the form ai plus bj, given its magnitude and the angle A it makes with the positive x-axis. Also find a unit vector and check its magnitude to be 1. Magnitude equals 14 and A equals 120 degrees.
Perfect. And so we already know how to tackle this. We have the formula here. We just plug in, the magnitude is 14 and alpha is 120 degrees. Let's do that. So we are looking at this formula and we're going to plug in. Now, 120 degrees. Reference arc is 60 degrees. 180 minus 120 is 60 degrees. Theta sub r, theta prime. There are different ways of writing it. So cosine and sine would be the same as 60 degrees. However, in the second quadrant, cosine is negative. So cosine of 60 degrees is 1/2, but 120 degrees is negative 1/2. Sine of 60 degrees is the same as sine of 120 degrees, square root of 3 over 2. Multiply by 14. There you have it. So that's in the form of AI plus BJ. How do you find the unit vector? Divide by the magnitude 14. Let's do that. Each one divided by 14 results in 1/2. So this is negative 1/2 I. This is plus square root of 3 over 2 times j. Now, what is important is to make sure we really haven't made a mistake. And that's why they say check. The way the checking works, if you look at the coefficients of I and j, okay, just like a squared plus b squared, right? If you square this one and square this one and add them up, you must get number 1. That is the key for the unit vector, because a unit vector is a vector in the same direction such that its magnitude must be 1. So let's do that. Negative 1/2 quantity squared, this is 1/4, plus square root of 3 over 2 squared, that means 3/4. They add up to 1, and the square root of 1 is 1. It's important to take a root, of course. 1 makes no difference. That's really the final answer anyways. All right. Let's look at the last question. Would you please read this?
A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree.
Perfect. So what we are looking at is this. We are going north 55 degrees east, so this angle is 55 degrees. The wind is blowing this way from west to east. Okay, so V with respect to air, V or speed with respect to the wind, W stands for the wind. And the result is, although we are going this way with the wind, it has an effect that this is the true course with respect to G or the ground. So that's what's happening. So we have to write each and every one of them to see how that works, and then add up their vector components as follows. So the velocity relative to air, we are doing 200 miles per hour, and theta, remember, the angle is with respect to the positive side of the x-axis. If this is 55, this is 35 degrees. So this angle is 35 degrees, this one, okay? North 55 degrees east means this angle is 35 degrees. What about the wind? The wind is going this way, parallel to the x-axis. So theta is 0 degrees for that, doing 35 miles per hour. So let us write each one using vectors as follows. The magnitude is 200 and the angle is 35 degrees. For this one, the magnitude is 35, the angle is 0 degrees. So let's write them down. So this is V of A. Now, this is not a common arc. You use a calculator and you plug in and you get those numbers. 163.83 I plus 114.72 J. The second one, we do the same thing. We put 35 here and we replace the alpha with 0. So we are using this formula as we used it here. Cosine 0 is 1. It's a common arc. And sine 0 goes away, it's 0. So 35i. And we are going to add the components for the two, because this is what happens. We are adding them up. So add these two up. And when we do that, this is I, add these two. 35 and 163, 198.83 I, and this one doesn't have anything to add to, you just repeat it. So this is velocity relative to ground. In order to give it more precise answer. Let's find its magnitude. Remember, the magnitude is the square root of this one squared plus this one squared. So let's do that. We're going to square this number. We're going to square this number, add them up, take a root, and it's 230 miles per hour, roughly. So the speed is 230 miles per hour. But what about this angle? Tan theta is y over x, which means 114.72 divided by 198.83. This is tan of theta. And it becomes almost 30 degrees. So this angle, we found it to be 30 degrees, everybody, 30 degrees. So if this is 30 degrees, that means this angle is 60 degrees, right? So we are doing 230 miles per hour. Here's north, here's east. So northeast. The angle in between is 90 minus 30 or 60 degrees. We have the speed and we have the angle.